Hey pre-calc students, welcome to today's lesson 5.6 Notes Day 3. As you notice, we are continuing on with applications of the sum and difference properties for trig functions like sine, cosine, and tangent. So just a quick reminder, you may use your calculator, but you still need to show every step. Okay, so if you could please go ahead and read the directions for the first two examples. Ask yourself if you think you know what they're asking. Okay, so if you notice, they're asking you to rewrite the expression into a single function, okay? So remember, our only options are sine, cosine, and tangent. So you have to figure out which of those fit the pattern in the expression. Okay, so in case you haven't noticed previously, the sum for sine, when you write them out, right, when you write out the pattern for sine of alpha plus beta, the binomial has sines and cosines of each angle, whereas the cosine multiplies the cosine of both angles and then the sign changes. Okay. And then, so like for example, if it's addition, it has cosine of both angles and then minus sine of both angles. So as I see that, I notice that I've got two cosines in the first multiplication, and then I have two sines in the second multiplication. So that makes me realize that this is a pattern for cosine. Now remember that cosine changes the signs of what the original angles were doing. So if the original angles were being added, then the pattern is going to have subtraction and vice versa, right? If the original pattern was subtracted, or sorry, if the original problem had a difference, then the pattern's going to have addition. So this one can be rewritten as a cosine function. But remember, it's going to be the opposite sign of what's in the middle, what the binomial has. So cosine of the first angle minus the second angle. Okay, so again, this matches the pattern of cosine of alpha minus beta. That's why I'm subtracting them. Now notice that direction said simplify it if possible. So I'm going to go ahead and subtract those. Feel free to take out your calculator at this moment if you can't do that on your own. And if it can be simplified, please do so. So as you look at it, they're asking for the cosine of 72. 72 does not have a reference angle of 30, 60, or 45. So that's the most we can do if they want an exact answer. If they wanted a rounded answer, I could have easily just made sure my calculator was in degree mode and then find cosine of 72. All right, for the next example, we've got tangent of 11 pi over 21 minus tangent of 4 pi over 21, et cetera, et cetera. As I start to compare to the patterns that we've been working with, it looks like this, which is the difference of two angles, the tangent of two angles, okay? So I'm going to go ahead and say, okay, well, I noticed that the numerator has a subtraction, so that means the original problem was tangent of alpha minus beta. So the pattern matches that of tangent of alpha minus beta. And so I'm going to set it up, tangent of the first angle minus the second angle. If possible, simplify. So 11 pi over 21 minus 4 pi over 1 equals 7 pi over 21. But 7 pi over 21 reduces to, you could reduce it by 7. So divide the numerator and the denominator by 7, and you get pi over 4. That is a reference angle that we've been working with. So pi over 4 is in quadrant 1. The reference angle is pi over 4. So if you think back to your 45, 45, 90, right? Triangle tangent is opposite over adjacent, which is 1 over root 2. But if you rationalize that, you get root 2 over 2. So again, these problems asked you to rewrite the expression as a single function. And of course, simplify it if possible. 72 did not have a reference angle related to 30, 60, or 45, but pi over 4 did. Okay, this next section is related to something that we did in chapter 4, and that's lesson 4.6. So if you have your notes organized, go ahead and pause the video and look for your notes for 4.6 and see if you can try to figure out how to set up number 3. Okay, so again, pause the video now, look through your notes for lesson 4.6. We spent 2 days on it, so you can look at both days and see if you can set up the problem for number 3. Push play when you're ready. Okay, so as I look at this problem, we've been given 2 important pieces of information. We've been given information about angle A, and we've been given information about angle B. We call them alpha and beta. Oops. Now that's just given information. Notice that what they want us to find is cosine of alpha plus beta. So this is the actual question. This is what we need to find. Okay. All right. So as I look to set up my information for angle alpha, notice they didn't give us what the angle is. They just gave us the sine of it. So that's opposite over hypotenuse. So as I set that up in quadrant 1, here's alpha, opposite over hypotenuse. Doing the same thing with beta. Beta is in quadrant 2. Remember, your reference angle is always to the x-axis, so that's why my 90 degrees are to the x-axis and the alpha and the beta are to the x-axis. Okay, tangent is opposite over adjacent. So opposite over adjacent. Notice I put the negative on the 7 because remember we talked about anytime you go left or down from the origin, those lengths are going to be negative. Okay, so remember, keep your eyes on the prize. They want cosine of alpha plus beta. So the pattern for that is cosine, minus, remember the sign switches for this pattern, sine of alpha, sine of beta. Notice that we are not being asked to find the angles. We're asked to find the cosine of the first angle alpha and the cosine of the second angle beta, sine of the first angle alpha and sine of beta. Those are ratios, okay? Now cosine is adjacent over hypotenuse, right? Adjacent over hypotenuse. And sine is opposite over hypotenuse. So as you look at the 2 triangles, we need the hypotenuse and the adjacent in each one, right? So what I need to do is I need to use the Pythagorean theorem to find the missing piece. So remember, it's the 2 legs that are added and squared, okay? So x squared plus 5 squared equals 13 squared. And then for this one, it's going to be -7. I always put my negatives in parentheses because I don't want my calculator to accidentally give me the wrong answer. Negative times negative is positive. So again, make sure that if you're going to use your calculator for -7 squared that you use parentheses. Okay, so go ahead and pause the video right now and find the missing pieces, the adjacent leg for the first triangle and the hypotenuse for the second. So please pause right now, find those links, and then push play when you're ready to continue. Okay, so I got plus or minus 12 and plus or minus 25. But for these problems, for example, the first one, it was in quadrant 1. So that side length should be positive 12, not negative 12. And then if you remember from chapter 4, the hypotenuse is always positive. So I'm going to go ahead and use the positive 25 for the hypotenuse. Now remember, they're asking us for cosine of alpha, which is a ratio. So cosine of alpha is adjacent over hypotenuse, so that's 12 over 13. Then they want the cosine of beta, which is negative 7 over 25. We're going to subtract the sine of alpha, which is 5 over 13, and the sine of beta, which is 24 over 25. And then you pretty much just put it all at once in your calculator, and your calculator should automatically reduce it. If it doesn't, in some of the older calculators, you can push math, enter, enter to reduce. Okay, so even though I've given you the answer, please take the time and pause the video right now to type that into your calculator and make sure you get the right answer. If you're having problems, make sure you show me how you're typing it in class the next time I see you. Okay, so now that you know how to do problem number 3 or you've seen it worked out, see if you can set up the information for example 4. Remember, you can pause the video to see if you could do it by yourself. Push play when you're ready. Okay, so they gave me a couple of reciprocal functions. So secant is related to cosine. It's just the reciprocal. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And cosecant is hypotenuse over opposite, which is the reciprocal of sine. Now, you don't have to draw two separate triangles because if they're in different or like two separate diagrams, if your triangles are in different quadrants, you can technically draw them in one diagram. Okay, I personally like to have them separate. Okay, so I'm going to go ahead and label accordingly based on the given information. Hypotenuse over opposite. Okay, and my job is to find the missing pieces. So remember, when you're setting up your Pythagorean theorem, the legs are the ones that are added and squared. So 3 squared plus x squared equals 5 squared, and x squared plus 5 squared equals 13 squared. So go ahead and pause the video, find those missing links. Be careful and make sure that you choose the correct sign, like is it positive or negative? Push play when you're ready. So right now, push pause on the video and find those missing links. Okay, so I got plus or minus 4 and plus or minus 12. But for our specific problems, we're going to want the negative links for both. Okay, so the signs of positive and negative are very important in these problems, so you want to make sure you don't mess it up. Okay, they want us to find the sine of alpha and beta. Notice they're never asking us for the angle alpha and the angle beta. They're asking us to follow the pattern for the sum of two angles when you're finding the sine. That pattern is sine of alpha cosine beta plus cosine alpha sine beta. Okay? And these are ratios. So that's why we needed to find the missing links because both of these require the use of opposite and hypotenuse. Okay, so now you just start filling in your ratios based on your triangles. Pause the video now and go ahead and put it in your calculator and then see if you get the same answer as me. Push play when you're ready to check. So pause the video right now, type this into your calculator, and then push play when you're ready to check your answer. All right, as always, if you have any questions, feel free to reach out. Hope you have a good day. Bye.